Hello, everyone. Welcome to the Operationalizing Microsoft Workloads session. We're glad to have you here with us today. My name is Lou Delatorre. I am with the Specialized Solutions Architecture team focusing on Microsoft Workloads.
Hi, I'm Siavash Irani. I'm a solutions architect here at AWS focusing on Microsoft Workloads.
Hi, my name is Purvi Goyal. I'm a product manager on EC2, also focusing on Windows and other enterprise workloads.
Thank you, guys. So we're going to be covering a few topics throughout this presentation. We have a few demos prepared for you guys. It's going to take about 60 minutes to complete the session, but we do have a meet and greet following the session. So if you have any questions, we'll be happy to meet with you guys after this session, and we'll have a slide with the details, but it's at the Willow Lounge just around the corner. But again, we're going to have a slide on that. So when you think about operationalizing your Microsoft workloads, what comes to mind? For a lot of administrators, that might be things like provisioning, building in some automation to provision your environment onto AWS, patch management, maybe remote access to be able to configure your EC2 instances within the cloud, backups, patching, monitoring, determining how your Windows servers are performing in the cloud. Also, it may include things like compliance as well as resource optimization. So what we hope to accomplish by the end of this session is to kind of take you through a phased approach, kind of like a life cycle management process of how you can leverage some of the services, some of the tools, the capabilities that we've built into our platform to help make your life easier when it comes to managing Microsoft workloads in the cloud. So we'll go through the agenda, which is going to include tools and services for infrastructure provisioning to help you automate those tasks, services for configuration management. We'll talk about monitoring and performance, governance and compliance, and then at the end, we'll cover resource optimization. So to get us started off with the first phase, I'm going to go ahead and hand it off to Siavash.
Thanks, Lou. So first, we want to talk about infrastructure provisioning. Let's take a three-tier web application using Microsoft Workloads in AWS. What are the steps that takes to build such an environment? First, you need to create a VPC. And by steps, I'm referring to manual steps. You got to create VPC, different subnets in different availability zones, bring up EC2 instances, configure IIS roles on them. In case you are using Microsoft SQL, you need to install SQL, add the role, and configure those. Security groups, those are usually kind of take time to make sure you're setting up roles properly. And also, in case you are using directory services, you can use either manage Active Directory or simple directory, or maybe you just have a trust back to your local on-premise environment. Now, all of this, if you do it manually, it's not going to be repeatable. If I want to build similar environment for different purpose, let's say for my development in another VPC, I cannot assure that the other environment that I'm building is going to be exactly the same. There's always a human error involved if I'm doing it manually. And also, it's time-consuming. I have to sit there and start configuring my environment. Well, all of this can be done using AWS CloudFormation Service. I know many of you are probably familiar with the tool. Basically, CloudFormation Service is infrastructure as a code service where you put all the components that you want to create with all the configuration in a template file, either JSON or YAML file, and then you either save it locally or in an S3 bucket, and then you have CloudFormation go ahead and deploy all those components for you. And it can be done both things that are at the AWS layer, like provisioning a VPC, security groups, ACLs, all the way to the things that are at the OS level, like configuring IIS role or Active Directory. Now, there are two big advantages of using CloudFormation. One is first is automated. An administrator can just start the CloudFormation stack. It's going to go read the file and deploy everything. And second is it's repeatable. So if you want to deploy it in another region for DR or maybe for just testing and development, you can use CloudFormation for that. Now, what I want to really highlight here, to even make it simplified for building those CloudFormation templates, we have AWS Quick Starts, these are reference CloudFormation templates, which are built by very experienced solutions architect here at AWS for different technologies, including Microsoft technologies. For example, we have a reference template that builds a complete environment with always-on SQL Server on it, and you can, or for Exchange or SharePoint. And what you can do, you can grab these templates and download them and customize it for your own workloads. And these can be accessed using a Quick Start URL down there. With that, I'm going to pass it on to Lou.
Thank you, Siavash. So we talked about infrastructure provisioning. Siavash provided a diagram of a 3-tier application, and perhaps you can keep that application in mind as we go through this process, or maybe think of an application of your own that you'd like to be able to manage and operationalize in the cloud. So let's say we've handled that provisioning. Maybe it was migrated or is a net new deployment using CloudFormation, as Siavash said. Now we need to take into consideration how we manage that environment in the cloud, whether it's .NET, IIS web servers, application servers, or database servers. So typically, most customers that migrate to AWS use some tools that they may already be familiar with, like, for example, remote PowerShell. They may use Server Manager. They may use plugins that go into the MMC that allow them to manage their instances. And this may include third-party solutions as well. And these are all fine, and they work just great, just fine in the cloud. But we've gotten feedback from customers that they've said they've wanted more cloud-friendly solutions for these workloads that are being deployed, and they wanted us to kind of take the heavy lifting off of their shoulders. So we've created a service called Systems Manager. It's been out for a little while now, and within Systems Manager, there's several different capabilities. We're not going to go into a Systems Manager deep dive in the session. There's plenty of other sessions on that here at reInvent that you can take a look at. But some of these capabilities that are within Systems Manager are critical to operationalizing your workloads in the cloud using our services. And these include services like, or capabilities like AWS Systems Manager Run Command, as well as AWS Systems Manager Session Manager. With these tools or these capabilities, you can perform some of the common administrative tasks that you may be performing to manage your instances in the cloud, like resetting the local admin password across a fleet of instances, or maybe restarting services, maybe updating group policies or policies on those servers, also configuring Windows Update services, as well as taking backups, whether it's using enterprise backup solutions or using VSS Snapshot, which is supported within Systems Manager. So you can leverage these capabilities to help you with managing your Windows instances. Now, AWS Systems Manager Run Command is a capability that's good to perform bulk administrative changes across the fleet of your instances. So you can use Run Command in the AWS console. You can use it in the AWS command line interface, as well as AWS tools for Windows PowerShell or the AWS SDKs. And this service and the capabilities are offered at no additional cost. So there's no cost for using these. You, of course, pay for the cost of the compute and storage that you're leveraging within AWS, but not for the use of this service. So Run Command is good for bulk administrative type tasks. If you need to perform some type of interactive configuration management or configuration changes on your servers like you normally would when you're using remote PowerShell, or maybe you're RDPing into the server to make configuration changes directly on that server on a one-off basis, well, Session Manager is perfect for that. Again, this is a fully managed capability that lets you manage your instance through an interactive one-click browser. It's a shell, basically running PowerShell on that instance directly. And there's no need to open inbound ports. There's no need to set up RDP gateway services or bastion hosts. So just think about some of the reduction in costs that you can gain by eliminating that infrastructure and instead using Systems Manager to be able to manage that environment. So here's just a diagram of what that looks like. The important thing to take away from this is how secure remote configuration management can be utilizing the Systems Manager service. So as you can see in this diagram, on the right-hand side, we have a VPC with the private subnet. We have web servers. For example, take that 3-tier application that you saw in the first phase. Let's say we have that running in this private subnet. You need to perform administrative changes on this. Maybe you need to reset IIS, for example, or maybe you need to change the password on these servers. You can do that all directly through Systems Manager. And what's really nice about this is that this is all logged and audited. So every change and the type of change that was made can be audited. It can be stored in S3, as well as CloudWatch logs. You can also be sent notifications via SNS topic whenever there's some type of change that you want to be notified about that takes place in that environment. So very secure remote configuration management. And again, no need to have any infrastructure stood up to be able to securely manage this environment remotely. So let's get into a demo on Run Command and Session Manager just to show you what that looks like. So Systems Manager is available via the AWS Management Console. There is a Systems Manager console, so when you go to log into AWS console, you basically select Services and select Systems Manager, which takes you to this page. And in this page, you have, again, a lot of other capabilities that we're not going to get into, but you can always take a look at this on your own time and look at the various actions that you can perform within Systems Manager. For the purpose of this demo, we're going to zero in on Run Command first. And let's say we have 10, 100, or even thousands of servers that we need to change the local administrator password on. Maybe we need to do that on a monthly basis because that's what's required by our policy, or maybe there is some type of breach on the password, or someone left the organization and now you need to immediately change the password on that. Well, you can easily do that using Run Command, and I'll show you how by simply clicking on Run Command, which is going to bring up the command documents. Now there's many different command documents that have been already created by AWS experts that apply for different things. And a document simply tells Systems Manager what tasks you want to perform against your managed instances or your EC2 instances. So for the purpose of this demo, since we're going to change the local administrator password, we actually want to run the run PowerShell script command document. And this is just telling Systems Manager that we're going to execute a PowerShell script or command on the managed instance that we're going to target. So I'm just going to grab a little snippet of code here. This is just a very simple example, but essentially we're going to just use net user on the local administrator and actually pass in the value of a parameter that we have stored in parameter store, which is another capability within Systems Manager. You can store your parameter values there. And I've got the password stored as a value in parameter store. So that's going to be passed in into that instance via Systems Manager. And then we're going to echo out what we changed that password to once we execute this command. So I'm going to go ahead and take this PowerShell command and paste it into my command parameters window. So this can be your PowerShell commands. This can be a script that you're specifying that resides within that managed instance. And you can identify it there. There's some additional settings you can specify. You can target your instances by tag. So if you had a group of instances, maybe you wanted all Windows Server. So you can create a tag for your Windows servers and then target them so that it performs this command against all of them. We're going to simply just select them manually. So we'll pick WIN01, and WIN02. And then below you see some other options, like you can enable rate control. So let's say you had thousands of servers, but you only wanted to target 10% of those at a time, or you wanted to set up some type of some error threshold. So if there were any errors, and it would just exit out and not continue on with execution, you can set those parameters there. As well as output options. You can enable writing to an S3 bucket so they can store those commands as they're executed. For the purpose of this demo, we're just going to disable that. You can also set up notifications, as I mentioned earlier. So we'll go ahead and just run this command against those two instances. So here we see that run command is in progress. Let's just go ahead and refresh this. And we see that it completed successfully. Now, if I click on one of these instances, I can click on the output, and you see there the command that was executed, and you can see the password, which I'll be changing by the end of the session. Same thing applies for the second instance, WIN02. You see that the command completed successfully. It tells you what the password was changed to. So just a very simple example to show you the power of run command. Now, there was no remote PowerShell involved in this. There was no remote desktop gateway services, no bastion hosts. This was all done via the service. Definitely a very powerful tool at your hand that you can leverage when you're considering your configuration management process within your organization. Now, let's say we just need to connect directly to an instance, and we need to maybe look at the services. Maybe there's some problem with the server, we're troubleshooting, and we need to go and look at a service. Maybe the service is stopped, we don't know what's going on with it, so we just want to go take a look at the services. Well, you simply click on Start Session. You select the instance that you want to start the session with, and I'm going to specify WIN02. Click Start Session. And it opens up Windows PowerShell. This is PowerShell running on that instance. So you're directly, you have direct console, interactive console with that instance. So now let's just type get service. And you see the list of services there. So if the service that I wanted, that I was interested in, showed that it was stopped and I needed to start it, of course, I would just start that service, and hopefully that would resolve my issue and the server would move on. There may be other applications that you would want to manage this way as well. Maybe you have an Exchange server, a SharePoint environment, something that leverages PowerShell commandlets. You can, again, log in interactively and manage that directly from Session Manager. So just a simple example there of how you can use these two capabilities to manage this environment. So now I'm going to switch back to our presentation. So besides interacting with your servers, being able to manage them, the configuration of them, or change passwords, there's a lot of other tasks, and we're not going to be able to cover them all in the session. But one that's very important, especially in a Windows environment, is patching your Microsoft Windows servers. So how do you do that? Well, many customers today use tools like Windows Server Update Services, or they may use the Windows Update settings on their servers to go to Microsoft and pull down the latest security patches and install them. Or they may have a third-party management solution, patch management solution. And that's all fine. That all works great within AWS. But we have created some capabilities within Systems Manager to help with that as well. The first capability is AWS Systems Manager Patch Management Solution. The second is AWS Systems Manager Maintenance Windows. So let's talk about what those do to help you keep your EC2 Windows Server instances up to date when it comes to patches. So Patch Manager is used to automate the process, again, of patching your managed instances. And it allows you to scan for missing patches, as well as scan and apply missing patches individually or to a large group of instances by using EC2 instance tags. For security patches, Patch Manager uses patch baselines that include rules for auto-approving patches within days of their release, as well as a list of approved and rejected patches. Security patches are installed from the default repository for patches that are configured for the instance. So that means if you're using Windows Server Update Services and you have that running within AWS, you can still continue to use that as your repository for those patches. You can just have Systems Manager manage that process for you. It'll respect any group policy settings that you have. So if you have them pulling them down from Microsoft, then that works as well. You can install security patches on a regular basis by scheduling your patches to run via AWS Systems Manager maintenance windows tasks. And basically, maintenance window allows you to set up recurring schedules for your managed instances to execute tasks that may be disruptive to your instances on a scheduled basis. So you may have a maintenance window for your organization that takes place maybe Saturday afternoon or Sunday evening, and you can set up a maintenance window to allow patches or any other tasks that may be performed, maybe using run command or automation, which is another capability. You can use maintenance window to manage that for you to ensure that it only takes place during that time frame. So two very powerful tools that can help you when it comes to configuration management. Now I'm going to turn it over to Siavash for automation.
Thanks, Lou. So not only we want to make sure that our instances are up to date and they are patched, one important task is keeping your golden images up to date. You don't want a user who launches an instance from an AMI taking a day to apply all those patches because the original AMI was so old. And basically, let's see what are the tasks involved if I have a very old AMI and I want to get to an up-to-date AMI. To do that, first, of course, I need to launch an instance from the older AMI. I need to update different AWS components, including different drivers, update the operating system, which usually takes some time, and update any other applications. You may have a specific software that you want to make sure it's patched and it's up to date, and then do a sysprep if required, and then create an AMI. And of course, after that, you need to clean that temporary instance that was created during the process. Well, all of this can be done manually and using maybe a script. But also, when you look at it at a scale and you want to, let's say, maintain hundreds of armies every month, having a script can be really problematic, and it requires a lot of maintenance. All of that can be done using AWS Systems Manager automation. So automation basically was built to simplify common IT tasks, which one of them is building AMIs. It could be different tasks, pretty much. Now, with SM automation, what you can do, basically, it's similar to CloudFormation. You can create and express your workflow in a JSON-based format file, and then have different steps and order of the tasks that you want to be executed, and have automation go ahead and take care of it. It supports for run command, Lambda functions, and also AWS APIs. Now, what I want to do here is actually I want to get to a demo section and show you how we can build an up-to-date AMI from an older AMI. So let's do that. OK. So what I have here, first from Systems Manager console, I'm going to open automation. And I'm going to click on Execute Automation. The document that I'm looking for here, it's called AWS Update Windows AMI. So I'm going to just type it in. And if I hit Next, what are the requirements for this document? Of course, the first thing is the source AMI ID. It's looking for that older AMI, so I can put it in here. For this testing, I'm going to just choose a AMI from previous month. And then I also need to specify IAM role for the instance that's created during the process, and also automation service role, which I'm going to leave it as default. Here you can even specify a certain naming convention for the new AMIs that are created. So similar to AWS public Windows public AMIs, which are released and they have a naming convention, you can create your own naming convention there. Here I can specify a specific instance ID in case required. This is also a subnet ID in case you want to make sure that that temporary instance is created in a different VPC while you're building it, so it won't conflict with any of your other running instances. You can specify that here. And there is a lot of control over what Windows updates and KBs to include during this process. You can control include or exclude different KBs. You can set categories or different security levels. Even you can specify publish date before and after for a specific patch. Now, two things that are important here is one is pre-update script and also post-update script, which you can use these basically to apply a patch to one of your third-party applications, or maybe specify apply a specific configuration to those applications while the update is happening. Now, what I'm going to do is I'm going to hit execute. What's going to happen here? It's going to list you all the steps that is going to be taken from this document, including launching the instance. So right now, actually, if I click on this, it shows even the instance that is currently running for this automation document. So basically, what it does, it launches the instance, checks the compatibility of the OS. Currently, it supports 2008 and above. Then it's going to apply and update all different AWS components. So you don't have to go in there and manually do it. It's all part of this automation document. And at the end, it's going to install Windows updates and run those scripts if you specify anything, any scripts there. And then it's going to sysprep the OS, stop it, create a new image, and clean up after itself. Now, because this is going to take time, I have created actually a finished version of this. So let's take a look at that. So this will be what you see. Basically, here's the output. That's the final up-to-date Windows AMI. And all the steps will be done. And basically, the input parameter that I specified here was the older AMI. Now, one thing you can do, as Lou mentioned about the maintenance window, you can combine this with maintenance window. Let's say you want to have monthly AMIs every month to be created. You can use maintenance window to kick off this automation document for every month. So you don't even have to worry about it. It just creates all those AMI in the backend. And because you have a specific naming conventions, user will know that they can go ahead and grab the latest AMI. So with that, I'm going to pass it on to Purvi.
Thank you, Siavash. I'm going to be talking to you about monitoring and performance management of your Microsoft workloads on AWS. So I'm sure many of you can attest that making sure that your business-critical applications are available and up and running is your #1 business priority in order to make sure that your business, to ensure that your customers are not impacted and you're providing a reliable service to your customers. Now, you also need visibility into how your applications are using these various resources so that you can identify performance bottlenecks before they impact your customers. As your application consists of multiple individual systems, such as infrastructure, Windows operating system, load balancers, IIS, and SQL databases, it can often be a daunting task to monitor all of them together. And with so many moving parts, looking for signs of problems and troubleshooting them can be challenging and time-taking, and often impact your customers negatively. This process may also add to your management overhead of requiring you to set up, scale, and manage your own monitoring system and infrastructure. As you may already have heard of Amazon CloudWatch, it is a monitoring and management service that provides data and actionable insights for your AWS, hybrid, and on-premises applications and infrastructure resources. Amazon CloudWatch provides a reliable, scalable, and flexible monitoring solution that you can start using within minutes without requiring you to set up your own monitoring systems or infrastructure. Using CloudWatch, you can perform a variety of functions, such as you can collect performance and operational data through built-in metrics for over 70 AWS services, through custom metrics, including your Windows performance counters, and logs, including Windows Server OS, IIS logs, as well as your custom application logs. This can get you visibility into your complete stack using a unified CloudWatch agent. You can also create high-resolution alarms on these metrics, as well as your log errors using CloudWatch alarms, and visualize all this data by creating a CloudWatch dashboard and visualize this data side by side. You can also take actions, troubleshoot errors, and get real-time insights into how your application is performing and optimize them, optimize your resources so your applications are healthy and up and running. So as mentioned, CloudWatch provides a complete unified monitoring solution that you can use to monitor your AWS resources. In addition to this, our customers told us that it can get quite challenging to accurately understand, detect, and troubleshoot what kind of problems are impacting their .NET applications. Some of these challenges include identification of right telemetry, setting up alarms on appropriate thresholds, and then manually looking for anomalies through various parts of your metrics and logs in order to determine what anomalies are happening. And then, in case of any problems, you need to manually correlate anomalies, sift through multiple alerts, alarms, and dashboards in order to find out what is really going on. So in order to help with this problem, we launched a new capability in limited preview called Amazon CloudWatch Application Insights for .NET and SQL Server to enable .NET monitoring and observability for your applications. Now, Amazon CloudWatch Application Insights can help you easily and quickly detect and diagnose common problems with such applications. To talk about the benefits, CloudWatch Application Insights assists in setting up the right telemetry for you, including metrics, logs, and alarms. And without you having to specify what thresholds to alarm on, the system learns over time and identifies what are the right thresholds for your applications and various metrics. As you can see on the slide, it also synthesizes .NET application logs, SQL Server logs, and various other logs to identify and highlight performance issues and surface common problems such as SQL Server backup failures and memory pressures in your application and databases through CloudWatch automatic dashboards with a summary of relevant metrics and alarms and log snippets of the issues. And this can enable you to pinpoint to the root cause pretty easily and quickly so that you can take actions and improve your overall customer experience. Talking about a few examples of what kind of problems you can detect using Amazon CloudWatch Application Insights. As you can see, you can detect problems such as SQL Server backup failures, scheduler deadlocks, .NET application errors such as memory leaks, common log errors, load balancer latencies due to memory contention, and so on. Think of a situation where your application load balancer is throwing errors, and it might seem like an application crash issue. And while you may think that there may be something going wrong with your web server or IIS, this might just be a problem with your SQL Server database. Now today, to determine the root cause of this overall problem, you may have to look through various alerts, dashboards, and logs, such as you can see IIS, SQL Server, OS, and so forth. However, with Amazon CloudWatch Application Insights, you get all of this data analyzed and grouped together in a single dashboard, so you can pinpoint to your root cause much quicker. Now, let me take you to the demo and show you how you can start using Application Insights and benefit from it. Okay, so as you can see, that's the home page of the service, and you can get started by clicking Get Started. So the way you onboard your applications onto CloudWatch Application Insights for .NET and SQL Server is through AWS resource groups. Some of you may not be aware of what resource groups are. It is a service that is provided by Systems Manager that you can use to group your resources together using tags. So if you don't have something already created, you can easily create by using tags and grouping them as a resource group. So here I have a few applications that I already have created. Like for example, I'm going to onboard my HR web app, which is a .NET 3-tier application, and configure it. So as I select this resource group, what happens is the tool identifies and scans your resources for your resource group to look for various components that make up your application. So for example, if you have a load balancer that has multiple target EC2 instances associated with it, you would see all these resources grouped together as one component. And what you can do here is select what tier is running for these resources. And if you have certain resources here that may not be relevant to your application or you don't want to monitor them, you can easily deselect them and hit next. So what would happen in this case is, once you make this selection, what happens is CloudWatch Application Insights determines what logs and metrics to monitor for various components of your applications that you selected. So in this case, as I selected two different components, one for my SQL Server and one representing my web tier, I can quickly identify and specify what my log file paths are, so that these logs can be entered into CloudWatch logs. Here I'm just going to enter my log file path. And as mentioned during the presentation, the tool also identifies and sets up metrics without you having to take any additional steps. As you keep using the service, it identifies and updates your alarms based on thresholds and depending on how your application reacts. So let's take a step back. And today, if you have to set up these metrics, logs, and alarms, you have to take a lot of manual steps in order to manually install CloudWatch Agent to your instances, and then set up agent configuration file with the desired configuration of your metrics, logs, and alarms. But with CloudWatch Application Insights, this process is templatized for you. So we provide a CloudFormation template, which, when you run, A, installs CloudWatch Agent, and B, sets up relevant configuration based on the logs and metrics that were recommended in the previous step. And with that is essentially the last step, and you're all good to go. So what I'm going to show you here is, I'm going to switch gears a little bit, and I'm going to show you the world's most important application, which is running on my AdventureWorks database. So, so a little bit background about what's happening. So a couple of hours back, I started receiving page from my test canaries telling me that one of my functions in the application has been failing. The function is edit. And as an application owner, what I'm going to do here is I'm going to try going into the application and try recreating this problem and see if my application really fails. So I'm going to click on edit, not make a change. Of course, so it seems like there is an error going on with my application. Now, today when I have to, of course, try debugging this issue, it seems like it is a very generic error on the load balancer on the front end. But to identify what is really happening here, I, of course, have to go back to look at what kind of alerts are happening with this problem, and then make a judgment call on to decide what is it that I can do to resolve this issue. However, I have already onboarded this application with CloudWatch Application Insights, and I'm going to show you how you can benefit from. I'm going to troubleshoot this issue easily using that. So here I am in CloudWatch Automatic Dashboards, which is essentially the home page for CloudWatch. And a good thing to note here is that I did not have any metrics or logs set up for this application before I onboarded it to CloudWatch Application Insights. And as you can see here, the tool created various alarms and metrics for me. I'm going to refresh. And as you can see here, it shows different alarms, different metrics that it set up for my application and various resources. The red line that you see here is essentially the metric threshold that was determined from the tool directly, and the blue line is where your metrics are performing. So an interesting part about this is when I scroll down, I also have an application insights section which shows me what are additional insights that were detected by the system for this issue that happened. So here it looks like it was a SQL transaction log full error, and I'm going to click on this to see what is really happening here. So as you can see, I see a short summary of what the problem is. It shows me what is the source of this problem. It shows me additional insights saying, hey, this is a 9002 error, which is a transaction log full, and I may have to empty my log space file by trying various steps. I can also provide my feedback on these insights once I'm done reviewing this problem, and I think if it's relevant or not relevant, so that the system learns over time, and the insights that you get for future detected problems are relevant to you and your organization. So, as mentioned, this single dashboard shows me the relevant metrics that are associated with this problem and have moved across because of this issue. This dashboard keeps updating as the system detects more anomalies, more alarms, and it keeps adding to this dashboard, so you don't have to look through multiple places to identify what's happening. So here, while it builds the dashboard, I'm going to see what is it that it's really, what was really found out for this issue. So it looks like it's throwing me certain errors on load balancer, on my SQL Server instance. So let me pull out this information for my log, which was also automatically pulled, and it shows me my log snippets. And it looks like my AdventureWorks database is full due to log backup issues. So what I'm going to do here is go to my SQL Server Management Studio and try running a backup on my database and see if that really resolves the problem. While I do that, I'm also going to run a dbcc SQL perf to see if that really made any difference. And yes, it seems like it should have resolved the issue. So I'm going to go back to my application and see what's happening here. So ideally, what should have happened while this page loads, I'm going to show you the same operation again and see if it resolved the problem. Seems like it is taking the request and trying to process it, and voila, looks like the issue is fixed. So what I can do here, of course, is go back to my CloudWatch dashboard, the insights dashboard that was created, provide my feedback, and that's pretty much it. So now I'm going to switch back to my presentation. Okay, all right. So as mentioned, this is a new capability that was announced this week for preview, and you can use the link on the dashboard to sign up for the preview. You can also use the QR code to land up with the same link. And with that, I'm going to pass it on to Siavash.
Thank you. All right. Please let me know if you need time to take a picture of that. But the slides will be available on SlideShare and also the recording on YouTube. So next thing we want to focus on is governance and compliance. Every organization has certain baseline and certain IT regulations which they want to make sure that their environment is in compliance with. But before we can do that, before we can see if our environment is in compliance with something, some standards, we need to keep an inventory of our whole environment. And what do we mean by that? You need to have a list of all the OS versions and their patch levels, all the software installations, all the application configurations, licenses, especially in Microsoft workloads where you need to make sure that you have enough SQL or Windows Server licenses for your environment. Or maybe it could be just network configurations, Windows registries, or pretty much any system property. You want to make sure that you have an inventory of it. And usually this inventory is dynamic. It's not something that you kind of export and save it into an Excel file. It's something that needs to be done on a scheduled basis. Now, today you may be using different tools to accomplish this, but also AWS Systems Manager Inventory Service was built to inventory all these different softwares and different applications and also OS versions in your environment. And basically, the data that it's captured from inventory service allows you to track licenses, track application assets, or discover new applications in your environment. Now, next, what I want to focus on is managing configuration drift. How many of you have heard the word that this used to work in my development environment and it doesn't work anymore. Many of you, right? I mean, it's very common. What is configuration drift? Is when a system configuration is drifted from its intended status. And there are different reasons that this could happen. For example, from hardware or software updates or system updates, or just a user or administrator going in there and modify configuration and forget to revert it back, which happens all the time. And a couple of examples we can refer to is like configuring RDP access. Depending on your use case, you may want to block RDP access because, as an example, maybe you have switched to session manager or run command for all your management tools. Or in some cases, maybe you have a remote desktop server where end users connecting to it, and you want to make sure RDP is always enabled. Or ensuring firewall routes. Although you set them up, someone may go ahead and change them. Enforcing a specific application setting. Or Windows activation. I've seen many times that where Windows just goes out of activation because like the KMS servers may not be set up properly, or the product key was removed from the system. Or sometimes you may want to make sure that any instance that you're launching is automatically joined to the domain. Like let's say if I tag my instances as like member servers, and I want to make sure that any instance that is launched with that tag is automatically joined to the domain. I don't want to go in there and manually join it or write a script to do it. I can set a configuration which applies automatically to my system. Or it could be just a bootstrapping with any specific configuration, and so on. Today, of course, there's different tools to accomplish this, but also you can use Systems Manager, State Manager to accomplish all these tasks. So State Manager is a configuration management tool which maintains consistent configuration across fleets of your instances. You can enforce configuration policies to your instances. And also, the big advantage is it works not only on EC2 instances, but also on your on-premise instances. So what I want to do here, I want to get to the demo section and just show you how I can use Systems Manager, State Manager to enforce a configuration to an instance. So let me switch to the demo. So what I have here is actually I've RDP'd to an instance. It's running fine. And let's say one of the policies is making sure the RDP is disabled because the new IT policy came in saying don't use RDP for managing instances. So what I'm going to do is I'm going to click on State Manager and click on Create Association. Why we call it association? Because basically you are associating a group of your instances or one instance with a specific configuration, with a specific document. And I'm going to just call it here, let's say, disable RDP. And the document that I'm going to choose here is actually the run PowerShell document. So it's exactly the same document that Lou ran while he was using run command to reset password. But in this case, I'm going to use it to reset RDP, disable RDP. But the difference in State Manager is I can set up a schedule to run this configuration based on a schedule that I define. Now, the command that I'm going to specify here is actually this command. This is basically, first, I'm disabling the RDP rule that allows RDP access. And second is I'm going to registry key for the RDP inbound. Basically, this is equivalent to system properties for allow remote connections. And I'm going to set that value to 1, which disables RDP. So I'm going to go ahead and copy this and paste it on the command. And let's say the policy that we had was maybe every 2 hours to run this. I'm going to set that to every 2 hours and create association. So what's going to happen is this RDP window will disappear, and it should disconnect after a few once the command is sent to the instance and the association takes place. Now, if I want to get back access to the instance, I can use a run command or session manager, or I can, if I want to revert it back, I can change my commands so it kind of re-enables RDP. Well, now that was one way to do it, but I want to also show you the DSC. I could do this also with PowerShell DSC. How many of you are familiar with PowerShell DSC or desired state configuration? Please raise your hands. Okay, few people. So for those who may not be familiar with PowerShell DSC, PowerShell DSC is basically is desired state configuration, where it's a configuration management platform within PowerShell, which uses a declarative method to apply configuration. And what does that mean? Actually, on the right side, what I have is the PowerShell DSC version of what I just applied to the system. In this one, on the left side, where I used run command, I had to give the system a command on how to disable firewall or how to disable RDP using registry key. But with DSC, you are not saying how. You are specifying what you want, what is your desired state, and system will figure out how to apply that configuration. So in here, basically what I'm saying is remote desktop setting, make sure it's absent. RDP role for remote desktop TCP, make sure it's blocked. And the system will use these different DSC modules, which are available both on PowerShell Gallery and also GitHub. System kind of grabs those and applies the configuration. Now, let's switch back to the systems manager. How would I be able to use PowerShell DSC with systems manager? If I wanted to do it that way, I could use this new document, which actually we released very recent, almost 10 days ago, which is called AWS Apply DSC MOFs. So basically, DSC, when you create this configuration and you run it, it creates a MOF file. And MOF file, or managed object format, is a file. Basically, it's a language for common information model for Windows. Basically, it's a language that Windows understands WMI and how to apply this configuration to the system. Now, when I run this, it creates a MOF file, and you can upload the MOF file to an S3 bucket. And in this document, apply DSC MOFs, first you can specify the MOF file that you created. I'm going to go through a couple of these different parameters that we can use here. MOF operation mode. This is actually a cool feature. You can sometimes you may not want to kind of apply a configuration. You may just want to get a report on what's going on with a specific configuration. You can just do a report only here. And where do you get the report? It goes in either you have options to upload it to an S3 bucket, or also it can send it to the compliance console here, which I'm going to show you in a few. Another couple of things that you can do here, if you create your own DSC module, you can upload that to S3, and it supports that. And also PS Gallery module source. So it supports PS Gallery. If your DSC depends on those modules that are on PowerShell Gallery, you can set this to true so it downloads them. And reboot behavior, you have a lot of control to kind of when to reboot after the MOF applies to the system. And a lot of different logging options. And here's the compliance type. Basically, in the compliance console, you can have custom compliance type. So in here, for example, I can set RDP settings. And so when the system gets a report, it can upload the compliance with that. And then you can choose instances. You can even set tags here for that. And you can set a schedule and compliance security and hit execute. I've actually already ran one. Let's take a look. So if you go to, for example, compliance window, you can see that this was the custom compliance item that I created. And you can see that one of them is alerted and is the instance, and because the RDP setting is not compliant with what I wanted to specify. With that, I'm going to pass it on to Lou.
Thank you, Siavash. So the last phase in the lifecycle management process is resource optimization. And when you think about resource optimization, some of the things that you want to optimize include costs, right? You want to get the most out of your investment on AWS. You want to optimize for performance. You want to make sure that those workloads and applications are performant. You want to enhance your security posture if possible. You want to ensure that fault tolerance is enabled for your applications. Also, you want to be aware of any potential service limits that you may be hitting, as well as storage optimization. And again, there's a lot of third-party tools out there that work great on our platform. We have many in the marketplace as well that are available for you to take a look at. But one service that we like to remind our customers about when it comes to the resource optimization phase in the lifecycle management process is the AWS Trusted Advisor. AWS Trusted Advisor helps you with all these things as well. In fact, for all customers, there are several core checks and recommendations that are available, including security and AWS service limits. So with security, you can check for things like S3 bucket permissions, ensuring that it's not available to the world. Also security groups, you can receive notifications about any security groups that may be open to everyone. IAM use, as well as ensuring that your root account has multi-factor authentication enabled on it. So there's a lot of security checks that we perform via Trusted Advisor and notify you about. Additionally, again, service limits, ensure that you're not hitting any of those service limits. Now, if you have business or enterprise support, which we encourage all customers to have for any production workloads that you're running in AWS, you get all these other benefits as well, including cost optimization. So let's say you did a lift and shift migration of your Windows workloads to AWS, which many customers do to get in the cloud, and then they want to optimize once they're there. Trusted Advisor will actually make recommendations based on your usage of those instances, and we'll actually tell you can save money by maybe selecting a lower instance type. So it's good to just check it out for that purpose to get the most out of your investment, as well as performance. So maybe you are hitting certain thresholds with regards to memory or CPU. Well, you'll get recommendations on what instances to select there as well. And we do fault tolerance checks just to ensure that your application is available. So definitely take advantage of this service of Trusted Advisor as you enhance or implement a resource optimization phase in your lifecycle management process. So at the beginning of the session, we kind of explained how we would be going through all the different phases in the lifecycle management process to help operationalize Microsoft workloads on AWS. In the infrastructure provisioning phase, we showed you how you can leverage AWS CloudFormation to help you automate your deployment of your infrastructure in the cloud, including using quick starts to help you with your Microsoft workloads and deploying products on top of those instances in an automated fashion using infrastructure as code. In configuration management, we showed how you can leverage AWS Systems Manager run command to perform bulk administrative tasks across your fleet, as well as Session Manager for interactive connectivity between to your instances so that you can manage them directly. We talked about Patch Manager for patch management of your Windows workloads in the cloud, which, by the way, supports Linux as well. If you happen to have Linux, you can use it for both. We also talked about automation to keep your golden images up to date in an automated fashion, so you don't have to manually deploy an instance from an AMI, update it manually, and then make it available for net new deployments. That can all be automated using automation. In the monitoring and performance phase, we talked about CloudWatch for monitoring, as well as Amazon CloudWatch application insights for .NET and SQL Server. Very cool stuff. So definitely go sign up for that preview if you're a .NET shop and you want to have visibility into how it's performing your entire stack. Very cool tool to be able to do that. Governance and compliance, we demonstrated how you can use State Manager to prevent configuration drift, and inventory to get inventory of your instance and what's running inside of your operating system. And then finally, in the resource optimization phase, Trusted Advisor to get the most out of your investment within AWS, to be able to cost optimize, to be able to ensure that your environment's secure and that you're getting the most out of your deployment in the cloud. So we encourage you to revisit your lifecycle management process. If you're using third-party solutions, that's great, but see if there's any areas where you can leverage our services to help with that, especially the ones we discussed. There are many other Microsoft sessions here at reInvent. Some of them have already taken place, but all the sessions will be available after reInvent for you to view. So certainly these are some of them. There are many more. You can find those in the catalog. We have a website, aws.amazon.com/Windows, which provides you with a lot more information on running Microsoft workloads on AWS. And of course, if you have any questions, reach out to your AWS account team or the AWS webpage and fill out the form, and someone will reach out to you, as well as partners. We have a large community of partners that have AWS knowledge, and Microsoft on AWS certifications that can help as well. So we have a meet and greet following this session. It's at the ARIA East Level 1 Willow Lounge. So it's in this tower, just to the right as you exit. It's Willow Lounge. And we'll be there for the next half hour. And we thank you for attending. Thank you.